mechanistic interpretability to detect hallucinations in the retrieval-augmented generation. And this paper is not didn't create any new technologies about the mechanistic interpretability, but it used the conclusions from the previous research about the mechanistic of the large language models to detect the hallucinations in the retrieval-augmented generation. And first, it may be confused that the retrieval-augmented generation is always used to reduce the hallucinations. But we find that in some cases, the retrieval-augmented generation can also produce some can also have some hallucinations. And first, we can have a case about this hallucination. So, what is rag hallucination? If we use a query that the large language model didn't know, and this query is about how to what the Chang'e will get from the get the samples from the moon. And this news is this query is a very new query, and the Llama 2 70 billion model didn't know the query. And if we don't append the retrieval document, the model will produce answer that is incorrect. And we can say that his parametric knowledge is not correct. So we can use the retrieve the system to retrieve some documents and append this document with the query. Then the model can answer this query correctly. And that's what we want the retrieval-augmented generation to do. But in some cases, we found that even we append a very correct retrieval document with the query, the model will also generate some hallucination answer, which is the conflict both with the retrieval documents and the parametric knowledge. And that's what we call rag hallucination. Is conflict with correct retrieval documents. And we can see that these two cases is all include the scenario that the model is the external knowledge is conflict with the parametric knowledge. But in some cases, the large models can give a correct answer, but in the other case, the model will give a hallucination answer. So in this paper, we want to detect and mitigate the hallucinations about even with correct context, and the IG can still generate unsupported or contradictory claims. And we want to use the mechanistic interpretability technology to detect this hallucination. So, we use some technologies in our mechanistic interpretability. The first one is about the copying heads, which is proposed by the Anthropic in a few years ago. And this technology is about the model. There are some heads in the large language models that they can attend to some tokens, and if they attend to some tokens, the tokens will highly correlated with output. And why this happened? The author said that because attention has OA matrix. OA matrix is WO and WV in the attention has. Because the OA matrix have many positive NG values, and so they will positively project the token embedding to the same direction of the token embedding, and they won't change the direction of the tokens. So this heads can directly have a positive influential to the final token predictions, and these heads are called copying heads. And we want to use this copying head to measure how much the model used the external context. And I will give additional claims that in the RAG systems, in the ID systems, there are two knowledge sources. The first knowledge source is the model's parametric knowledge, and the second knowledge source is the external context. So we want to measure how much the model used the external context and how much the model used his parametric knowledge, and then we can detect the rag hallucination. And just now I have introduced the copying head. It's used to measure how much the model use the internal context. And if we can detect some attention heads as the copying heads if they have very much positive engines. And these heads are called copying heads. And if these heads have a very high attention rates to some tokens, and we can confirm that they want to copy the token information to the output tokens. And